This is section 9.1 titled Intro to Geometry. So in this chapter, chapter 9, we will be talking about angles and lines and planes, and it should just be a really fun chapter. So I'm really looking forward to doing chapter 9 with you guys. To start off, I wanted to talk about, there's lots of different terms we need to know, and we need to be able to refer to them all. So make sure that when you take these notes that they're very neat, that you can turn back and say, how do I name that? What is the notation for that? That's the most important part. So we'll start off with a point. That's our first vocabulary word. It is a location in space. Anywhere in space, it is one location. It has no size. It is just a dot. So how we draw that is we would do a dot, and then usually we'll label it with a capital letter. We can name it P, we can name it A, we can name it B, whatever letter we want to name it, but just make sure it's a capital letter. The notation, or how we name that, is we could write it out, point P, or we could just write a capital P. But we need to make sure we always use capital letters. Okay, so that is how we talk about points. We could call it point P or just P, but make sure you use those capital letters. Then we have a line. That's our second vocabulary word, and it is a series of points that extends infinitely. Okay, so if I have, it's in two directions and it's straight. So if I have a point, if I draw it, lines are always going to have arrows on both ends. I could have point A, point B, point C. Okay, and it's going to go on forever. It does not have a depth, a width, or height. It is just a line of points. Okay, because I could put a line or points along anywhere on this line, and it's going to be part of our line. And it goes on infinitely. It goes on forever. Okay, and our notation for a line, if I wanted to talk about line AC, I would write it like this. Again, this means line when I put the line with two arrows and then the two letters I want to. So I could have line AB, I could have line BC. Okay, so that is how I would name this line, or however I'm talking about whatever line. So this is the important part, that I drew a line, arrow, arrow, and put my letters underneath it. Okay. Next word that we have is a plane. Okay, a plane is a flat surface that extends infinitely. So think about like a shape. If I have a square, it would just be like having this square right here. It is a flat part of my 3D shape, except for I extend it on forever. Okay, it keeps going. It is a flat, it's kind of like a flat piece of paper that keeps going forever. Okay, but we have to think of it as flat. It extends infinitely in all directions, but it has no thickness, right? A piece of paper is not very thick, so it would be even thinner than a piece of paper. It is just a flat plane. Okay, so how I would draw this is something like this. Okay, again, we know it goes on forever. I have my points A, my points B. This is just random. Don't think I'm putting these on here so that it's something specific. Okay, so if I named this, I would name it plane ABC. Again, notice all of my points, because they're referring to points, they're all capital. So we need to make sure we're using all capital letters. So this is how I would name a plane. I would just call it plane ABC, or if this was D, point E, point F, then this one I would call it plane D, E, F. Okay, so that's just what I would call it, plane whatever. And again, it is flat, has no thickness, and it extends on forever. Next word is the line segment. It is a series of points on a line between two endpoints. Okay, so our line went on forever. Our line segment looks something like this. Again, see there's 2 points instead of 2 arrows. This is line XY. So how I would write this is, line segment. Its name, if it's asking you to name it, then I would just write XY. If it's asking you to measure it, measure how long it is or whatever, then we would just write XY. Okay, so but mostly when you're naming things, you're going to put that line over the top, not the arrows, because the arrows indicate a line, so we just have to put a line because that line stops. So the difference between a line segment and a line is a line goes on forever. Line segment, it's just between those 2 points. Again, notice how we're using capital letters because we're describing points. Our next word is ray. Okay, a ray is a series of points that extends infinitely in one direction. Okay, so this is what a ray looks like. I would have a point. My point is P. Let's say I have another point, Q. But this is the difference between a ray and a line segment, is it has this arrow. It goes on this way forever. Okay, infinitely, only on one end though, right? Because this stops at P. So how I would write this one is I would draw a line, then I use my capital P, my capital Q. Okay, I would not say QP, because then that would tell me that the P goes on forever. But nope, it touches the Q and then it goes on forever. So we have to make sure that we put them in order. Okay, that does matter. It will be wrong in a test if you get them mixed up. So let's just make sure we are careful with that. Our next word, looks like we have an example here. Okay. Here's our example. We have a line, and this goes da-da, da-da. I have my A, my B, my C, then I have from point B going up, I have a point D. Okay, A, B, C, D, there we go. So we need to name 3 points. Again, remember I can name them point A, point B, point C. Make sure they're all capital letters though. Oh yeah, that was a comma. Okay. Name 3 rays. Okay. So we have a ray right here from A to B. So I can say B, A, ray, right? Because it touches the A and then it goes on forever. Then I have B, D, ray, and a B, C, ray. So those are my 3 rays. Remember, we put them in order from the end of the segment to the ray, to where it goes on forever. Name 2 segments. Okay, so I have segment AB, right? If I stop them there, they can be done. And I can have segment BC. I could also have segment BD. Okay, that just means I'm describing what's in between these 2 spots, these 2 points, I should say, and these 2 points. Okay? Then we have to name our one line that we have here. Our one line is, remember we have to make it go on forever, AC. Goes on forever. That is why it is our line. Goes on forever. Okay, so now let's go and try some new things. This is kind of a separate idea. So on my notebook, what I would do is I'd take my little scribble, my pencil, and I'd scribble a line because these are kind of new ideas that we're going to put in. Okay, so again, we have more vocabulary words. We have our intersecting lines. So instead of this time, we're not just talking about one ray, one line segment. We're talking about pairs. We're talking about two of them, two or more. Okay, so if we have two intersecting lines, they're lines that have one point in common, and they would look something like this. Again, they're lines, so they're going to go on forever. Okay, so we have to make sure we put our arrows on the end. Let's say this is point A, point B, point C, point D, and point E. Okay, so we can say that line AD intersects line EC. EC, and it intersects at point B. Okay, that's where they intersect, at that point B. It's just wherever they intersect. It doesn't have to be right in the middle. It just has to be they are going to cross each other sometime. Okay, then we have perpendicular lines. And perpendicular lines are lines that intersect at a right angle. I'm going to do my best to draw a right angle. Probably will not be perfect, but what I'm going to do is I'm going to draw that little box, which means it is a right angle. Okay, so then we have point B, point A, point C, and point D. Okay, so our notation, or how we say that these are perpendicular lines, is we would say line AC is perpendicular, that's how we draw perpendicular, to, oh my goodness, what am I doing here? Okay, line AC, let me try that again, is perpendicular to line BD. Okay, so again, this means perpendicular. I had to kind of squeeze it in there a little bit. Okay, so that's how I would write it. AC is perpendicular to line BD. Then we have parallel lines, and parallel lines are lines that are on the same plane, so they are on that same flat surface, that do not and will not intersect ever. Okay, so let's say we have a line that looks like this. Goes on forever, again they're lines. Then we have a line that goes like this. Okay, they are on the same flat surface. This is point E, point F, point G, and point H. Okay, so how we would write this is we would say that line EF is parallel. We just draw two lines like that to line GH. Okay, so that's just how we say that those lines are parallel to each other. Okay, then we have a thing called skew lines. So skew lines are lines that are not on the same plane. They are not on the same flat surface. And they will not intersect. So they're kind of like parallel lines, but they, again, are not on the same surface. And how we would see those is if we were looking at a 3D shape. Okay, so here's my flat plane. Then let's say I brought my square back, my cube, sorry. Okay, so let's say this is point, right here is point A, point B, point C, and point D. Okay, so I would say that line CD and line, AB, sorry, these are segments. Segment CD and segment AB are skew. Okay, so you can see they're not on the same flat surface. Okay, if I had this point that was E and this point that was F, then I could say EF is parallel to AB. Okay, do you see that? They are on the same flat surface of this front shape. They are on the same surface. Okay, but AB is on a different surface than the CD, which is in the back of the shape. So that's why those are skew lines, but at the same point, they're never going to intersect. So they do not intersect and they are not on the same plane. All right, now let's do an example of this. Our example is actually going to be another box, like I just drew right there. Okay, so this is what our example looks like. I'm going to try and draw it big so we can really get a good picture of this box here. This cube, shall I say. Okay, something like that. So back here, I'm going to bring it down a little bit. Back here we have point C. Here we have point E. And here we have point F. Point G. Point A. Point B. Point, what is that back there? Oh, this one right here in the front is point D. And then back here in the back is point H. Okay, so those are our points of our cube here. Name a pair of perpendicular segments. So we have to think of two segments that have right angles. Remember, perpendicular looks like this. Okay, so I could say line, again we're talking segments, line segment AG is perpendicular to, so I'm picking on, let me pick a different color here. We'll go this one. Okay, I'm picking on AG is perpendicular to DG, right? If this is a cube, we know that that angle is a right angle. So I can say line DG. Okay, so there's a pair of perpendicular segments. Then it says name a pair of parallel segments. Okay, so our parallel, I could pick this AG and BD. Again, that's not the only one. I could do DG, BA, I could do DG, EF. They just have to be on the same flat surface or same flat plane. I could pick ones in the back, I could pick ones on the side, I could pick ones on the top, lines on the bottom. There's lots of options. I'm going to pick one of line BA is parallel to line DG. Line segment, I apologize. Line segment. BA and DG. Name a pair of skew segments. Okay, so for this one, I'm going to name segment BC up here and segment FG down here. Segment BC and segment GF are skew. All right, that is all that I have for you for section 9.1. Make sure if you have any questions, you come in and get help. And thank you for watching.